San Francisco has lived with the big one in the background for generations, a threat everyone knows is coming but still imagines as a single isolated disaster. New research quietly tears up that idea and replaces it with something worse, a chain reaction in which a megaquake in the Pacific Northwest helps to wake up the very faults that run past San Francisco's front door. So, what's the deal? Let's take a look. The story starts with Cascadia, the subduction zone stretching offshore from Northern California to British Columbia. It's one of the rare systems on Earth capable of magnitude 9 earthquakes, the kind that don't just rattle a city, but redraw coastlines. In January of 1700, Cascadia did exactly that. The giant rupture tore along most of the zone and launched a tsunami that crossed the Pacific, leaving behind a signature that geologists can still see today. For years, that 1700 monster was treated as a regional story about Oregon, Washington, and Vancouver Island. The latest work says that's only half the picture. When researchers examined cores and trench records along the northern San Andreas Fault, they found evidence that something else happened in the same time window. The sediments point to a major rupture on the northern San Andreas following close on Cascadia's heels, likely a quake comparable in size to the 1906 San Francisco event. More worrying, that pairing doesn't look like a one-time coincidence. Over the past 3,000 years, the same pattern keeps appearing. The team identified 18 large Cascadia earthquakes whose timing lines up with major events on the northern San Andreas soon after. Not every Cascadia rupture seems to trigger California, and not every San Andreas quake can be neatly tied back to Cascadia. But the correlation is strong enough that after 2 decades of work, scientists like Jason Patton and Chris Goldfinger now argue that the nightmare scenario, a Great Cascadia quake helping to set off a Northern California rupture, has to be taken seriously. The statistics only sharpen that warning. For the southern part of Cascadia, the average repeat time for giant earthquakes is around 220 years. On the northern San Andreas, the average interval between major events is roughly 200 years. Probability models give Cascadia alone about a 1 in 3 chance of producing a great quake in the next 50 years. That, by itself, would devastate the Pacific Northwest and parts of Northern California. But if even some of those Cascadia ruptures are capable of pushing the northern San Andreas over the edge, then San Francisco and the coast down toward Hollister are not waiting on a single isolated fault. They're tied into a larger cascading system. There's one uncomfortable exception, the 1906 San Francisco earthquake. It's the only major event on the northern San Andreas in millennia that doesn't appear to have been preceded by a great Cascadia rupture. The fault that tore the city apart in 1906 has already proven that it can deliver a catastrophe on its own. The new research simply adds another layer. In many earlier cases, history suggests that it didn't act alone. Cascadia went first. All of that is careful, peer-reviewed science. But to understand what it means for people living around the Bay, it helps to look at how fragile our idea of stable ground already is. Under normal conditions, California's vertical land motion is painfully slow. Ground-based GPS, satellite radar, and tide gauges track uplift down to the thickness of a fingernail. Most of the coast moves by a few millimeters a year, sometimes sinking as groundwater is pumped out, sometimes rising a little where sediments pile up or the crust rebounds. The rule is pretty simple. You measure change in millimeters per year, not feet per day, and any report on the land jumping by feet overnight would shatter that framework and leave experts scrambling for answers. Even with that slow world, the coast can behave in ways that feel anything but reassuring. Portuguese Bend, just south of Los Angeles, is the proof. Heavy rains in the winters of 2022 and 2023 soaked the clays beneath the hills, reactivating deep sliding plains that had been dormant for generations. Instruments recorded parts of the slide moving up to 30 centimeters a week, far beyond anything in local records. At the front edge of that moving mass, where the slide slams into harder rock near the shoreline, the land doesn't just move sideways. It crumbles upward in what engineers call toe uplift, or ground that has run out of room to move forward and is forced to rise instead. Field teams from JPL and local agencies have mapped domes, cracks, and subtle bulges along that coastal bluff, all driven by water, gravity, and geometry. The message for the rest of the coast is blunt. Even without a major rupture, the margin of California is capable of rearranging itself in ways that break roads, pipes, homes, and budgets. Now, place that fragility on top of a multi-fault earthquake scenario. Let's say Cascadia ruptures in the north, sending powerful seismic waves down the margin and subtly shifting stress where it meets the San Andreas. Then, minutes or maybe hours later, the northern San Andreas lets go from offshore Humboldt down past the Golden Gate and inland toward Hollister. In that scenario, major West Coast cities are no longer watching each other's disasters on the news. They're in a crisis at the same time. Resources that might barely stretch to handle one catastrophe are suddenly being pulled in several different directions at once. Ports already vulnerable to gradual subsidence have to contend with seabeds and quay walls warped by shaking. Lifelines that cross the fault, water mains, power lines, fuel pipelines, fiber optic cables, fail in multiple states simultaneously. And as always, the people with the least margin are hit the hardest. Renters in older soft-story buildings, communities on artificial fill around the bay, coastal towns built on ground that amplifies shaking and liquefaction. Now, if that still sounds like a distant worst-case scenario, it is worth looking at another place that never lets scientists forget how limited their models really are. Mount Etna in Sicily. For more than 3,500 years, Etna has erupted so often that geologists describe it as an almost continuously active volcano. Its magma system has been mapped in detail, and thousands of rock samples have been cataloged, and yet it still produces eruptions that bend the rules with unusual magma chemistry or sudden flank collapses that send flows racing down toward the sea. Each surprise at Etna forces scientists to admit that the system is more complex than the models built to explain it. The same lesson applies to San Francisco and the wider Pacific coast. Recurrence intervals for Cascadia and the northern San Andreas have been estimated. Probabilities have been calculated. Building codes and retrofits have improved since 1906 and 1989. But history, both along California's shoreline and at restless places like Etna, shows that Earth has a habit of treating what we call the worst-case scenario as a starting point rather than an upper limit. If Cascadia and the northern San Andreas do fail in sequence again, it will not feel like an abstract probability. It'll feel like a system-wide shock that hits San Francisco and the rest of the West Coast in ways current planning only partially captures. The question is no longer whether the Bay Area sits on dangerous faults. Everyone knows it does. The real question in light of this new evidence is whether we are prepared for those faults to awaken as part of something larger, faster, and more interconnected than anybody wanted to believe. And whether, when the next great rupture begins, people will look back at studies like this and admit the Megaquake risk was increasing in plain sight, while everybody tried to convince themselves the clock could be pushed just a little bit further back.